Hello YouTube, around this side. So today I have a very interesting tool to cover for Kubernetes cluster. So the tool name is MetalLB, which is a open source load balancer, which we can implement in our Kubernetes cluster, which is built on premises or maybe on the cloud. So any of the cluster type can use MetalLB. So let us first in So let us first introduce that why we are using MetalLB for on-premises cluster. So as you may already know that we have a service type load balancer in Kubernetes. So for that, if we are using cloud and on cloud we have built our Kubernetes cluster, then we can easily use load balancer and immediately we can use ingress as well within the cluster. But this does not happen in the case of on-premises, and it is a very tedious task to set up the load balancers for on-premises clusters or on bare metal cluster as well. So MetalLB has a functionality or the features which made it very easy to set up and possible to use load balancers in our bare metals and on-premises clusters. So instead of using cloud, we can also use load balancers in our on-premises clusters. So you may be already familiar that if we have declared our service type as load balancer and we are using the non-cloud cluster, then the status will always be pending and we are not assigned with external IP so that we can access the application outside the world. Means like we cannot share the application to other guys or to other people so that they can review it. So for that, in today's video, we will be like going through MetalLB and get to know that how we can implement the same in our cluster. So let us first understand uh, what is the architecture of MetalLB. Yeah, so if we see this diagram for MetalLB, so here you can see that here we have a router, and router is routing the traffic inside the cluster in which we have deployment in our node, and we have MetalLB load balancer service which we have set up using MetalLB. So whenever any traffic reaches to the router, then it routes the same to our node, and using MetalLB load balancer service, we can access or the user can access the service outside the world. So this is a very simple tool. So MetalLB provides two features, which is IP address allocation, and uh, another one is I guess advertising, means uh, announcement of the service IP by the speaker. So I have created that demo, and I have written down the manifest file in my GitHub repository. So you can also use the same. So let us first understand that what is inside the manifest file, which we will be implementing in our demonstration. So let us first go to the IP pool. So this manifest, which is of kind IP address pool, and here the API version, which you can see that it's MetalLB. So because it is using the CRDs of MetalLB, so this is the API version of it. This is the kind. This is the name we have given, and this is the addresses. So this is in this addresses we can give a list of uh, address IP addresses which we are provided, and we can give any range of the values for IP addresses, no, but be sure that the IP addresses should not overlap with DHCP protocol. So means if the protocols, if sorry, if the addresses which are used by DHCP, then please try to avoid them. And apart from it, you can give any IP addresses. So in IP address pool, this is the one component of MetalLB, which is IP address allocation. So here we are just simply giving the range of the IP addresses which we want for our application to use as it as a load balancer. So whenever we will be creating any application and when we will be denoting or mentioning the service type as load balancer, so the service will take any random IP from this range of the IP addresses which we have given. So this is IP address pool, and we have to also apply this manifest, which is L2 advertisement. So basically, in MetalLB, we can use two type of uh, announcement. One is layer 2 mode and another one is BGP. So you can also go here in the official MetalLB page website, and here you can see that MetalLB in layer 2 mode and MetalLB in BGP mode. So in MetalLB in layer 2 mode, if we have two or three nodes in our cluster, uh, so MetalLB will pick one of the node in the cluster and made it as a speaker. So speaker is nothing but the component which handles the load balancers IP addresses and sync those load balancer with the application. And so you can also go through like how to set up L2, and in the installation also in the configuration, yeah. So in the advanced L2 configuration, you can go through like what is L2 mode here. So here this is the same. In L2 mode, only one node is selected to announce the IP from, and normally all the nodes where a speaker is running. So speaker is a component which handles IP addresses for the load balancer, and the it is synced with IP address pool, which we have already seen. Sorry. So yeah, so L2 advertisement is the kind which is there for L2 mode, and it picks up a node in the from the cluster and assign it as a speaker, and then that node is responsible to handle the load balancers for the service type. And in the BGP, so in the BGP, each node will be assigned as a speaker, and each node has the flexibility of routing the traffic, and they can use the load balancing feature easily. So here you can see this is the manifest file. If we have to start with IP address pool here, and we just have to give a BGP advertisement as a kind, and we have to sync the BGP kind with the address pool, which we have already like which is already there in the documentation, and we have other specs or other fields as well if we have to like modify our manifest. So in my demo, I have kept the things simpler so that you can easily try out the things like how the things are working, and you can also play around the same. So this is my app one. So in this video, I will be deploying two applications, and they have their deployment and service each. And here you can see that I have not given any type to my application. So if I have not given any type for the service, then it will take cluster IP as default. And it is a very simple app. So in the deployment, you can see that this is the metadata section, This is the labels I have given. This is the specifications for the template, specification template for the container, and this is the port which is used by the application, and this is the service for the same. Same goes for the application too, uh, and yeah, I think I have to correct this. Okay, so this is a simple application. App1 and App2, same fields, same ideology here as well. I have not given the type cluster IPs or any type for the service. And I will be also using ingress so that we can access the application by just giving the routes. So here you can see kind is ingress here. This is the name for it. This is the annotation, and I'm using Nginx ingress controller for deploying or for using the ingress. So I've given ingress class name here. In the host, I will be providing the DNS name so that we can access the application. This is the path. So in this path, /1 means my DNS name /1 will direct the application, uh, which is using app1 as service name. And when I will be doing like appending the URL with /2, then it will sync or redirect the website or web application to app2 service name, and it will display the content of that service. So app1 and app2, these are the service name which I have already given in the manifest file. So this is app1 and this is app2. So in the ingress, we just have to pass the name of the services which we want to navigate and redirect the traffic. So in the host, currently you can see that it is blank, but in the demonstration, I will be modifying the host because it's dynamic, or what we can say that when everything will be applied, then we will get the IP address, and then I will be converting that IP address as a into a domain name or something which we can resolve with the IP address so that we can access the application. So this is a very simple demonstration for MetalLB. So let me just give the summary in short. So MetalLB is Metal Load Balancer, which is a open source tool for and in which we can introduce load balancers to our on-premises and bare metal clusters because we know that using load balancer we get a DNS name so that we can access the application in from the browser or to outside the world. But this feature is the load balancer feature is not currently available for the clusters which are built on bare metals. So MetalLB is solving that issue, and MetalLB has two features. One is IP address allocation, and another one is announcement. So IP address allocation is nothing but giving the set of IP addresses or the range of IP addresses so that the Kubernetes uh, will allocate the random or the set or the IP address from the IP address pool to the service which are using load balancer as a type. And in announcement, in so announcement or speaker is a component in which we can announce or we can use the router so that router can redirect the traffic to the correct service type, and it is synced with IP address pool so that it can easily navigate the user to the correct load balancer IP. So let us jump directly to the demo. Let me first copy the URL of the Git repository so that I can clone the same in our Kubernetes cluster. So in this video, also I will be using Killer Coda for my Kubernetes cluster. So it is still loading. Okay, let's check if it is working fine. So here you can see the Kubernetes version is 1.30, and in this playground, we are given with two nodes. One is control plane, and another one is node 01. Okay, so let's install the CRDs and other operators. So we can install MetalLB using Helm and with manifest as well. Both of the things works the same, but for just if you are using manifest, then first try to create the namespace as metallb hyphen system, and then apply this git url, or means this uh, CRDs and operators URL, so that it will install the same in this namespace, because everything written in the operators use MetalLB system as their namespace. So, but in this video, I will be using Helm, and Helm is default with the killer code. So I don't have to first install the Helm. So I will just directly apply these commands, and it will install MetalLB in my system. So here you can see that MetalLB has been deployed successfully, and MetalLB is now running in the cluster. Okay, after installing after installing MetalLB with Helm, I will be using Nginx Ingress controller. So Nginx and Ingress controller is nothing but a controller which has set of CRDs and other stuff, which is used to run Ingress in the cluster. So although Ingress is a native service, but it is not provided as with default in the Kubernetes clusters. So we have to add the controller like separately, and we have to first install the controllers and then apply the manifest, which will be using Ingress. So directly copy this, paste this. So it definitely takes time because it has many service accounts, operators, CRDs, etc. to install and set up in the cluster. We can check if we get any output from the previous command. So here you can see that it has been it's working fine. Let me just check if everything is running correctly or not. Okay, so let's. I think I have not cloned the repository. Let me clone it. Okay, git clone. Okay, so we are moving inside the MetalLB demo directory here. So first we will apply IP pool YAML file, so that it will allocate the IP addresses for the load balancer or for the MetalLB to use them as a load balancers. And then we will apply L2 advertisement, means layer 2 advertisement YAML file, so that it can sync with IP pool file, and it will start like it will start assigning the external IPs to the services. So both of the files has been created. means applied successfully. So let us check which address they have given to our ingress controller, because the same we have to use for our ingress file. So here you can see previously the external IP for our ingress Nginx controller was in none and or in the pending status, but now you can see that it has provided external IP, which is 172.20.0.120. So if you will notice that in the IP pool YAML, uh, we have given this range of IP addresses. So 172.20.0.120. So it has started giving the correct IP address. So this is the first load balancer service which we can say that we have installed in our cluster. So it has given the first IP address from the range to our Nginx controller. So everything up till now is working fine. So let us just okay, I've cloned. So now let's just apply the applications. So I'm directly applying both of the application. So you can also, if you are not aware that you can also apply multiple files in a single command. So here you can see that app1 is created, the deployment for app1 is created, and the service also, and the deployment and service for app2 is also created. So these all are created in the default namespace. So let's check if they are running or not. Everything is running fine. We can see that one replica of my app1 is running and one replica of app2 is also running. Mm, Let's check the service type as well for the applications. So as you know that in the manifest file, I have not given any type for my load for my services. So Kubernetes has assigned them cluster IP, and external IP is none, and these are the port for the application. Okay, so let's. Okay, so now just few minutes back in this video, I have explained you that in the ingress for the host, I have not I have kept the field blank because we have to uh, because we have to allocate or fill the host with the IP address or the DNS name. So in the host, what we have to do is we have to just mention the IP address of our Nginx ingress controller. So we can get that from here, kubectl get all -n engine. So here, okay. So here we have to use the external IP of this service, which is ingress nginx controller. So let me first copy this. It will not work currently. I will also tell you, and what is the resolution we can perform to solve this issue. Basically, whenever we will be using Nginx ingress or any ingress tool. So in the ingress manifest file, in the host, we usually give the DNS name of our load balancer. So here you can see we have not provided with the DNS name. We are provided with the IP address. So this file will not be saved, and when we will apply this, it will not work, and it will throw an error for us. So here you can see the ingress app12, which is the name of our ingress file, is invalid because we have given an IP address, and it should be a DNS name. So to solve this issue, what we can do, we have a short trick here. So we will just uh, map this IP address to DNS name for our local cluster so that we can access the application in the cluster using curl command. So just to solve this issue, we just have to go to etc slash host directory, and let's just copy this IP address. Okay, so this is the file in which we have all the IP addresses which are like mapping to any or to multiple DNS or other host. So here we will just simply paste the IP address of our Ingress Nginx controller, and we will give a name so that we can use it as a DNS name. So let's do this. Let's write this as a metal lb.demo. So you can give any name, and let's save this. Okay. So now let's again modify our my ingress YAML file, and instead of this IP, we have to just give the name of the DNS or the host which we have written in etc host. Now save it, and now apply this again. So here now you can see that it has successfully created. We can also check everything. Okay, let me do this again. So this is the section for the pod services, daemon set, deployment, and replica set. Let us check ingress. So here you can see that now the host is MetalLB.demo. So let us just access this application using curl. Okay, so here you can see that when we are doing curl MetalLB.demo, we are getting 404 not found. So if we'll again check what path we have given in our ingress.yaml which we have written. I will simply write cat. Okay, let me clear this first. So here you can see that whenever the host name is metal.lb.demo and for path /1, we will be redirecting to the service or to the application which is using service which is named as app1. So what does this mean? That if we use URL as metal.lb.demo/1, we will be seeing the content which is running the application one app1. And if we modify the URL and use /2, then it will redirect to the service which is running our second application. So let us do this. Copy this and clear the screen, and again access the application using curl. And now we just have to paste this. So here you can see that curl metal.lb.demo/1, we are getting output of hello world because this is the image we are using. So in the image, the application we have written is that uh, it should print hello world, and the version is 1.0.0, which is default, and it should print the host name. Host name is nothing but the pod. So you can check the pods. So app1 5F67, starting with 5x67. So here you can see 5F67, and it's ending with 625 VB. 625 VB. So it is correctly synced with the pod, and it is displaying the correct application. And again, we can use another URL which we have written for our ingress. And now we just have to modify the URL from 1 to 2. And now we will be seeing another application which is using the same image, but it's printing and displaying the host name for the pod. So here you can see our app2 CB86D 75BD hyphen LD 5x5. So this is, the English is working fine because it is correctly syncing the application with the pod and the pod ID. So this is how we can use English controller, and we have also seen how we can use MetalLB for our on-premises cluster. We can also use MetalLB in various Kubernetes clusters, which we can create using Minikube, Kind, K3s, and etc. So for those, we just have to additionally install the add-ons in the cluster, and we can simply use. If you guys like my video and you like this demonstration, so we can I can also make a video like how to install the same setup in Minikube, and we can also access the application in our Chrome browser or any browser in our local system. So I hope you have liked the video, and this is a new and interesting tool which we can use in our cluster, and uh, I hope you will play around with the tool, and I will be pasting sorry I will be mentioning the URL of my GitHub repository so that you can also check the things, and if you want to raise an APR or you want to modify the configuration for the IP pool or Elto advertisement or any like announcement mode, so you can also like do the same and feel free to raise a PR if you like. So I'm ending the video. Hope you guys like the video. Thank you.